Bloody hell, dude. I am so obsessed with integrals. I'll just actually tell a story before I start this video, man. So, I actually did really terrible in maths in high school, man. I think, like, I did the basic math class, and, my tutor put it this way. He said to me, "What did you do for the entire year? Did you bang your head against the wall? Like, how do you get a grade so bad?" So I live in Victoria, Australia, and we've got this system called the VCE, whatever. And I did the basic further maths, and my grade was so if you get a 30 out of 50, that's equivalent of like a C plus, and I got 21. So, yeah, I was very bad, dude. But now look at me. Look at where I've come from. And I remember the only motivation for me to get good at calculus was I liked how sick the symbol of the integral looked. Like, it looks cool. I don't know, man. I should have taken arts. Anyway, that's my story. The only reason I good at math is because I like the look of the symbols. So let's get into it, man. This is a cool integral. I know it is because I've done it before and I know exactly how to solve it if I screw it up. Oh man, except, you know what, I pride myself on how good my integrals look, so that's terrible, man. Okay, I am giving up. Hang on. Alright, whatever, that's good enough, man. So 2x tangent minus 1 of x dx. Alright, what looks the hardest? Obviously this there, so u is equal to arctangent of x. Oh, not dx. I'm so sorry, dude. Du is equal to 1 over 1 plus x squared dx. dv is equal to 2x. V is equal to x squared. Cool. We know how to integrate 2x, yeah? 2x is x squared. So 2x squared over 2, well, 2's cancel out, so it's just x squared. Cool. So let's apply the integration by parts formula. So uv, arctangent of xv, so x squared arctangent of x. I like saying arctangent because it makes me sound more fancy. I think that's the only reason anyone ever says arctangent. So x squared arctangent of x minus the integral of v du. So that's x squared times over 1 plus x squared dx. Man, this looks so much harder, man. You can't take a u substitution. What do you do, man? But remember, if you watch my u substitution videos, I've got a neat trick for this one as well. So I'm going to do the trick called split the fraction, plus 1 minus 1, because that's still 0. Now watch this. X squared arctangent of x minus the integral of x squared plus 1 over 1 plus x squared dx minus the integral of 1 over 1 plus x squared dx. Are you seeing where this is going now? So what's this? X squared arctangent of x minus, well, this is just 1 dx, so minus x minus, but remember this minus was being applied to the whole thing. So this is actually plus the integral. That's that you've got to be very careful about that. So this minus sign here applies. If you alter this integral in any way, if you do integration by, oh, sorry, you're not even on the screen. So this minus sign applies to this whole integral. If I alter this integral in any way at all, this minus sign applies to all of that. So if I take integration by parts again, this minus sign applies to the whole integral. So x squared arctangent of x minus x plus the integral of 1 over 1 plus x squared. Well, remember that the derivative of arctangent of x was 1 over 1 plus x squared. Doesn't this look kind of familiar? That's right. So I'm basically taking it back to arctangent of x, man. So the integral of 1 over 1 plus x squared is the arctangent of x. And that's plus c. And that's my final answer. But because everybody that loves to make the solution look nicer, I'm going to find out what's coming. Well, I know that arctangent of x is coming. So let's do this. Hang on. Yeah, let's do it. So arctangent of x, x squared, cool. Arctangent of x, plus 1. No, that looks terrible, man. Let's take out x. So that's x arctangent of x. Oh, I've already written it out. X arctangent of x minus 1 plus arctan x plus c. Doesn't that look a lot better? I think so. So this is x squared arctangent of x minus x plus arctangent of x plus c. That's my final answer. And how cool is that integral, man? So, like, the only cool thing about it is that I had to split the fraction, but doesn't, and the fact that the minus sign applies to the whole thing. That was the cool part about this integral. And the fact that I don't know, it's just a cool question, man. Anyway, see ya.